the exponential function with the natural base and the natural logarithmic function. First, we'll talk about the natural exponential function. It is an exponential function whose base is e. F of x equals e power x, and the x belongs to R. So the natural exponential function is it is an exponential function whose base is e. Because we'll study another exponential function whose base is another number like 2, 3, half, any real number. But now we will study the exponential function whose base is e, such that f of x equals e power x and x belongs to R. So the power here is a real number. When we draw this, the curve of the exponential function, we notice that the curve passes through the point 0 and 1. When you substitute x equals 0, so f of 0 equals e power 0 equals 1. So we have the point 0 and 1, and when you substitute x equal 1, we have the point 1 and e. F of 1 equals e power 1, which equal e. So we have these 2 points, 0 and 1, 1 and e. And this is the curve of the exponential function. So the domain of the function f, where f of x equals e power x, is R, and its range is open interval 0 to infinity. The range from 0 to infinity. This curve will not touch x-axis, and the curve of the function passes through the points 0 and 1, 1 and e. Here 0 and 1, 1 and e. F of x equals e power x is 1-to-1 function, because when you draw a horizontal line across the graph, it will cut the curve at only one point. Any horizontal line cuts the curve at only one point. So the function f of x, e power x, is 1-to-1 function that accepts the existence of an inverse function, is called the natural logarithmic function, and we will study it later. So limit e power x when x tends to infinity equals infinity. Limit e power x when x tends to negative infinity equals 0. Second, the natural logarithmic function. It is a logarithmic function whose base is e, and we write f of x equals ln x, such that x belongs to R positive. So the domain of this function is the positive real numbers greater than 0. And this is the curve of ln of x. Its base, it is a logarithmic function, its base is e. We know that the common logarithm, its base is 10. But when the base is e, we call it natural logarithmic function. And the domain of the function where f of x equals the ln of x is r positive from 0 to infinity, open interval, and its range is r. The curve of the function passed through points 1 and 0 and e and 1. When you substitute x equal 1, so we have f of 1 equals ln 1 and the logarithm of 1 always equals 0. And when you substitute x equals e in this point, so f of e equals ln e, which equal 1. Here it will be logarithm e to the base e, so it's equal 1. It is an inverse function for the function y equals e power x, and this is clear from the graph. Here we have y equals e power x, and this curve, it is y equals ln x, and this straight line, it is y equal x. So the logarithmic function of the base e is the image of the function y equals e power x by reflect on the straight line y equal x. So the inverse function of y equals e power x is y equals ln x, and limit ln x when x tends to infinity equals infinity, limit ln x when x tends to 0 equals negative infinity. For the symbol ln x is used in any graphic program like GeoGebra to graph the function. Some properties of natural logarithm. Some properties of the natural logarithm. The natural logarithm has the same logarithms properties. So we start with this. If x belongs to R positive, here we denote to the domain. Again, if x belongs to R positive, so the domain is all the positive numbers. Of course, it's greater than 0. And y belongs to R, a, it's the base, belongs to R positive minus 1. Then the form ln x equals y is equivalent to the form e power y equals x. Here is the exponential function e power y equals x, and it's equivalent to the logarithmic form ln x equals y, because you can write this as logarithm x to the base e. So these two forms are equivalent forms to e power ln x equals x, and you have to memorize these rules to use it in solving problems. E power ln x equals x, 3 ln e equals 1, ln 1 equals 0, ln 1 equals 0, log x to the base a equals ln x over ln a. And we use this rule to change the base. Here the base is e, here the base is, here the base is a, and the base here is e. So logarithm x to the base a equals ln x over ln a. Here the base, we consider it e. For each x and y belongs to R positive, the set of positive real numbers, and n belongs to R, we have ln x multiply y equals ln x plus ln y. Again, the product of, we have here the product of xy. Ln xy equals ln x plus ln y. And ln x over y equals ln x minus ln y. And ln x over y not equal ln x divide ln y. Ln x over y equals ln x minus ln y. Ln x power n equals n ln x. This is the power property. Ln x power n equals n ln x. 9. Logarithm x to the base e multiply logarithm e to the base x equals 1. It is a property of the multiplicative inverse. Logarithm x to the base e multiply logarithm e to the base x equals 1. Example on limits and the natural logarithm. Prove that limit a power x minus 1 over x when x tends to 0 equals ln a, where a is greater than 0. Again, the required to prove is to prove that limit a power x minus 1 over x when x tends to 0 equals ln a. Ln a. And this is a very important rule. We will use it to solve problems. Solution. First, let y equals a power x minus 1. This numerator, a power x minus 1, consider it equal y. So when x tends to 0, then y tends to 0. How is that? When you substitute x equals 0, you get a power 0. And the a power 0 equals 1. 1 minus 1 equals 0. So when x tends to 0, so also y equals 0. So we can substitute or replace x tends to 0 with y tends to 0 in the limit. A power x equals 1 plus y, and from this we can write a power x equals y plus 1, and we write it. Then by taking the natural logarithm to both sides, we will take the natural logarithm here to both sides. So ln a power x equals ln y 1 plus y. By using the property of power logarithm, we have here x as a power. So we can write x ln a equals ln 1 plus y. Again, x ln a equals ln 1 plus y. And from this, we can find x equals ln 1 plus y over ln a. And we write it. X equals ln 1 plus y over ln a, and this is 2. This is equation 2. From 1 and 2, we have here in 1 y equals a power x minus 1, and we have when x tends to 0, we replace it with y tends to 0. So limit a power x minus 1 over x when x tends to 0. What is the value of a power x minus 1? It is y. Divide x. When you divide ln 1 plus y over ln a, we write ln 1 plus y in the denominator multiply ln A. We converse it. We write the multiplicative inverse of this fraction because we write it here in the denominator. So limit a power x minus 1 over x equals limit y over ln y 1 plus y multiply ln A. And we simplify it. It is equal y in the numerator equals 1 over y in denominator. Again, y in numerator equals 1 over y in denominator. It is the same. So we can rewrite this form in this shape. It will be ln A over 1 over y ln 1 plus y. Substituting here, we have x tends to 0. We replace it with y tends to 0. Y tends to 0. And we use the property of power logarithm in the denominator. So instead, we write 1 over y ln 1 plus y. We write ln 1 plus y all power 1 over y in this form. So this limit equals limit ln A over ln 1 plus y all power 1 over y as y tends to 0 equals ln A over limit ln 1 plus y all power 1 over y. So we take the limit for both numerator and denominator. Ln A, it is a number, it is a constant. So limit ln A equals ln A. It is a constant number, like 2, 3, half. Again, limit ln A equals ln A. And we have in the denominator limit ln 1 plus y all power 1 over y as y tends to 0. Here, what is the value of this? So we have ln A, and we can replace ln with limit. So this form, we can write it in this form to be ln limit 1 plus y all over 1 over y when y tends to 0, and limit 1 plus y all power 1 over y when y tends to 0 equals E. We studied in the previous lesson. So this fraction will be ln A over ln E. And what is the value of ln E? Ln E from the previous properties equals 1. And we write ln A over 1, which equal ln A. So limit A power x minus 1 over x when x tends to 0 equals ln A. And of course, we will use it in solving problems. And the previous example is used as a rule to solve the problems. You can also use the following limits to solve the problems, and we will memorize it. 1. Limit logarithm 1 plus x to the base a over x when x tends to 0 equals logarithm e to the base a. Second rule, or you can say third rule, limit ln 1 plus x over x when x tends to 0 equals 1. Exercise. Choose the correct answer. Limit 2 power x minus 1 over 3x as x tends to 0 equals one of this. So we will solve this limit. We will simplify it. We find its value. Solution. We have the rule limit a power x minus 1 over x when x tends to 0 equals ln A. And this is a condition here. A always greater than 0. It will not be negative, this base. How we use this rule to solve this problem to find its value? We have limit 2 power x minus 1 over 3x equals 1 over 3 limit 2 power x minus 1 over x. So we can take 3 out of the limit to be 1 over 3. Limit 2 power x minus 1 over x. And this is the form of the rule. This is the form of the rule here. Considering a equals 2. So the value of limit 2 power x minus 1 over x as x tends to 0 equals ln 2. Here in the rule equals ln a. So we have ln 2. So the value of this fraction equals 1 over 3 ln 2. And the answer will be B. 2. Also choose the correct answer. And this is the used rule. Limit ln x over x minus 1 as x tends to 1 equals 0, 1, e or e power negative 1. This is the used rule. Limit ln 1 plus x over x when x tends to 0 equals 1. We have to connect between the problem and the rule. First, when x tends to 1, then x minus 1 tends to 0. Why we start with this? Because we have the limit when x tends to 1. And the rule here is x tends to 0. So, when x tends to 1, then x minus 1 tends to 0. Then, limit ln x over x minus 1 when x minus 1 tends to 0. We replace x tends to 1 by x minus 1 then tends to 0. And by replacing x with x plus 1, we get, here we replace x by x plus 1. We replace x by x plus 1. We get limit ln x plus 1, replacing x by x plus 1, and replacing x by x plus 1, negative, negative, 1, 1, and we complete. Don't forget, we substitute x here by x plus 1. So we replace x by x plus 1 in the whole limit. So what we get? Limit x plus 1 minus 1 equals x. So instead of this, we will write x tends to 0. Ln x plus 1 over x plus 1 minus 1, which equal x. But the rule is limit ln 1 plus x over x when x tends to 0 equals 1. So we write 1. So we convert the problem itself, we convert the limit to the form of the rule. The form of the rule is limit ln x plus 1 over x. Here it is ln x over x minus 1. We convert it by replacing x plus 1 with x. So the answer will be B. Find the limit 1 plus 2x over x when x tends to 0. and we will use this rule to solve this problem. How? Solution: when x tends to 0, then 2x tends to 0. Multiplying both sides by 2. 2 multiply x equals 2x. 2 multiply 0 equals 0. Then limit. Here we write the problem itself, the original fraction. Limit ln 1 plus 2x over x when x tends to 0 equals limit multiplying up and down by 2, because we have 2x in the original fraction, so multiply up and down by 2. We have 2 over 2, so 2 multiply ln 1 plus 2x over 2x when 2x tends to 0 equals, what is the value of ln 1 plus 2x over 2x? Again, what is the value of limit ln 1 plus 2x over 2x when 2x tends to 0? It is equal 1 according to the rule. Note that we have here the coefficient of x is 1 in all the limit. The coefficient of x is 1, 1, 1. So if you have the coefficient is 2, 2, 2, also the result will be 1. If you have limit ln 1 plus 3x over 3x when 3x tends to 0, always equal 1, also equal 1. That's why we multiply here by 2 to be in the form of the rule. But when you multiply the denominator by 2, you must multiply the numerator also by 2. So the result equal 2 multiply 1, which equal 2. 4. Find the limit ln 1 plus x square over x square when x tends to 0. Again, back to the rule. Here we have x, x, x. If you have here any other symbol, a, so the result equal 1. If you have x square, x square, x square, the result also equal 1. So to solve this limit, we must convert it or put it on the form of the rule. Solution: since x tends to 0, then x square tends to 0 by squaring the two sides, and we can replace the limit. So limit ln 1 plus x square over x square when x tends to 0 equals limit ln plus x square over x square when x square tends to 0. We substitute x tends to 0 by x square tends to 0, and we write it. Now we have the form of the rule, which equal 1. 5. Find the limit e power negative x minus 1 over x when x tends to 0. We have a rule for this. Limit e power x minus 1 over x when x tends to 0, it's equal 1. It's equal 1. It is equal log e to the base e. Log e to the base e, which equal 1. So limit e power negative x minus 1 over x when x tends to 0, it is the original limit, we write it, equals negative, we're multiplying the limit by negative and the denominator by negative. Of course, when x tends to negative, when x tends to 0, then negative x also tends to 0. So we multiply the limit by -1 and the denominator by -1. So we have the form of the rule. What is the form of the rule? Limit e power negative x minus 1 over negative x when negative x tends to 0 equals 1. But we have the sign, the negative sign out of the limit, and we write it. So we used this rule. Limit e power x minus 1 over x when x tends to 0, it's equal 1. And if it was e power negative x over negative x, here is negative x, also the result equals 1. So the result here in problem 5 equals negative 1. Find the limit a power 2x minus 1 over x when x tends to 0. Here, note that the limit in the form of the rule, but there is something different. Here the coefficient is 1, the coefficient of x is 1, the coefficient of x is 1. The coefficient of x is the same in x here as a power, in x as a denominator, in x here, the value of x. But the coefficient here is different. The coefficient of x is 2, the coefficient of x is 1, the coefficient is 1. So we wanted to write the limit in the form of the rule with the same coefficient of x. So we will multiply the limit by 2, multiplying up and down by 2. Here, 2 over 2. 2 divided 2 equals 1. So we will not change the value of the limit. We only change its form to be as the rule. So limit a power 2x minus 1 over x when x tends to 0 equals 2 a power 2x minus 1 over 2. We're multiplying up and down by 2. And when x tends to 0, then 2x also tends to 0. And we write it. What is the value of this limit? It is ln a, ln the base, ln a. And this is 2 here. So the result will be 2 ln a. 7. Find the following limits. Limit 1 plus 3 tan square x cotan square x when x tends to 0. And also we will use this form of the limit. We studied already in previous lesson. Let cotan square x equals y, then tan square x equals 1 over y. As we will take the reciprocal to both sides. What is the reciprocal of cotan square x? It is tan square x. What is the reciprocal of y? It is 1 over y. And when x tends to 0, substituting x here equals 0, then y tends to infinity. Then y tends to infinity. Then when x tends to 0, then y tends to infinity. Again, cotan square x equals 1 over tan square x. And the tan x equals 0. So 1 over tan square tends to infinity. It means y tends to infinity, and we write it. So limit 1 plus 3 tan square x power cotan square x when x tends to 0 equivalent to limit 1 plus 3 over y power y as y tends to infinity. We have two equivalent limits. Substituting tan square x by 1 over y, and we write it 1 over y multiplying by 3, we have 3, we got 3 over y. and cotangent square x, it is equal y. So we have the power here is y. What is the value of this limit? It is e power 3. As limit 1 plus a over x power x equals e power a. If a equal 1, we have this limit equals e power 1 equal e. Of course, don't forget that x tends to infinity here. So limit 1 plus 3 over y all power y, when y tends to infinity, equals e power 3. E power 3. Here e power a, here e power 3. Number 8, find the following limit. Limit len 1 plus 3x square over 2x square when x tends to 0. So as x tends to 0, squaring the two sides, then x square tends to 0. So the original limit, we write it equals 1 over 2. We take 2 out of the limit here. These two, we have 1 over 2, it's half. Limit len 1 plus 3x square over x square. And you know that as x tends to 0, then x square tends to 0. So, but we need 3 here, so multiplying up and down by 3. So 1 multiply 3 over 2, limit len 1 plus 3x square over 3x. This form always equals 1. So we write 1 multiply 3 equal to 3. 3 over 2 multiply 1 equals 3 over 2. And this is the value of the original limit. It will be 3 over 2, but it is necessary to make it in steps.